Hey guys, and welcome back. We are now in our first lesson of our second semester, and we're talking about exponent properties in Unit 4. So as you know, this is going to be a really short unit, and we're going to get right to the rules and making sure that you have lots of practice before we get to our test, okay? So we have two learning targets, simplifying using one property of exponents and simplifying using multiple properties. So we're going to start off with each one, and then we're going to slowly put them together so that you can practice them all at the same time, okay? So the first thing I want to look at is called the product rule of multiplication, right? So step one is going to be to multiply the regular numbers, or in our case, we know them as the bases. So the base is the number that is telling you what to multiply by. So if I had 7 to the third power, 7 would be my base, and then 3 would be my exponent or my power. Okay, so we're looking at multiplying the bases. When we're multiplying the bases, we're actually adding the exponents. All right, so this is going to be addition for those exponents. Now, this only happens with the variables when they are the same. So if it's bases that are numbers, then it's okay to go ahead and multiply them. If they're just variables, then we're actually just going to keep that same variable. So this would be an example here of x times x, same base. So we're going to add those exponents together, and it gives you a plus b because we can't actually add a and b together. So when we talk about these, let me see if I can, I don't know what's going on. Can't scroll. Sorry, couldn't get the paper to scroll. So let's talk about these ones we have coming up. So again, same bases here, x and x for this first one. So if they're the same bases and you're multiplying them, we're going to keep the base and we're going to add our exponents. So 2 plus 3 would be like this, and we would have x to the fifth because we could actually put 2 plus 3 together. So this would be our final answer because you can't take x to the fifth power. Okay? The next one on the right gives you an example of when there isn't an exponent. So we know that if I had 9, really that's like saying 9 to the first power because the answer is still going to be 9, right? So anytime there isn't an exponent, then that means you're pretending that there's a 1 there, okay? So if no exponent, then it is a 1. All right, so this would be like a to the ninth times a to the first. Again, the a's are the same base, so we're going to keep that base. And then 9 plus 1 would actually give me a to the 10th, and that would be our final answer. Okay, now we move on to ones that have coefficients, which means they have a number out in front. Now, keep in mind, if I were to just get rid of these two things, the problem here would be 5 times 6. So we would go ahead and do that. You're going to multiply those regular numbers. That's what I was trying to tell you up top in those rules. So 5 times 6 gives me 30, right? I've taken care of that part. Now we're looking at the bases with the variables. So x and x are the same. So x is going to come there. And then we've got 2 plus 4 because we're adding those exponents when we're multiplying. So this becomes 30 x to the sixth. Okay, so you're multiplying those coefficients or those numbers out in front, and then you're going to keep that other base for the variables the same. Okay, so this problem is exactly the same, only instead of putting the dot for the multiplication, we gave you the parentheses for multiplication, but it's the same exact thing. So I could put a little dot here and it'd be the same stuff. So again, we have coefficients out in front. This is multiplication, so we're going to go ahead and multiply those. Now we're going to look at the exponents with the variables. So again, we can't take x times x, so we're going to do base of x, and then 6 plus 2, because we're multiplying, we're going to add together. So that gives me 15x to the 8th. And that's your final answer because you can't actually take that one to the 8th power. Okay? getting a little bit more involved down here as we move down. Same exact thing again, but now we've added in another variable. So coefficients, this is still multiplication, like there's a dot there. 8 times -3 would give me -24. My x's would be 4 and 4. So that would be x to the 4 plus 4. My y's are 2 and 9. So y is to the 2 plus 9. Now, you're not going to have to write out that addition problem every time. I'm just doing it to show you where we got those numbers when we're done. So -24 stays. We didn't change that. 4 plus 4 gives me 8, and 2 plus 9 gives me 11. And there's your final answer because you can't combine those terms because they have different bases. Okay? So add exponents of the like terms every time. Okay, so this one, on the last one here, is just different because it has 3 separate terms. It's still all multiplying, you see here with the dots. So now we're going to take 3 coefficients and multiply together. So 2 times 5 times, -5 times 3. Well, this gives me -10 times 3, which is -30. Then I have a y here with nothing, so that's a 1, remember? So I've got y to the 1 plus 2 plus 3. Well, 1 plus 2 is 3, and 3 plus 3 is 6. So my final answer is -30 y to the 6th, because you can't take that to the power. Okay, hopefully that's making sense. Let's move on to our second power. So when we're in a multiplication problem, we're going to add exponents. When it's a power to a power, like an exponent on the outside of an exponent, then you're going to multiply those powers together. Okay? You're going to raise the coefficient to the outer exponent, so this number would actually be distributed there, and then you're going to use the power rule. So what would happen is we're basically going to distribute this guy to everything on the inside. Okay? Let's do a couple examples, and that'll make sense, hopefully, as we go. So this just has one coefficient. It's x, right? So there's only one thing to multiply. So I'm going to take 5 times 2 here. We're multiplying because it's power to a power. So this is x to the 10th. So if you want to think about it as a little explanation, x to the 2 times 5, right? It's being distributed. And we can't actually take x to the 10th, so that's our answer. Now, here's an example of one that has 2 different bases. Remember that c has a 1 next to it because it doesn't have an exponent right now. And this is what I was talking about with distributing it. So it has 2 separate terms. So we're going to distribute this 3 to 2 separate things. C to the first is c times 1 times 3. And d is 2 times 3, which means this is c to the third and d to the 6th. And we can't combine those because they're different bases, so this would be your answer. You're distributing that number on the outside, the exponent on the outside, to everything on the inside as a power. We're multiplying it, okay? So, same thing down here. Now, the difference here is we're only distributing this guy to the things on the inside of the parentheses. So this -4 on the front, nothing happens to it. It just drops. This is a 1 next to our m, so we're distributing the 3 twice. This is m to the 1 times 3, and then n to the 4 times 3. And again, you don't have to write all those problems out. If you know 1 times 3 is 3 and 4 times 3 is 12, you're just going to start with the answer. So -4 stays, like I said, 1 times 3 is 3, and 4 times 3 is 12. And this would be our final answer because we can't combine anymore. Okay, doing great, almost there. The next one is an example of having a coefficient and 2 variables on the inside of the parentheses. So now we're distributing to 3 different terms, the 2, the x, and the y. So again, the 2 doesn't have an exponent, so it's like taking a 1 out here. The x's are 2, and then the y has a 1 because it doesn't have an exponent either. So the 5 is going to go to all 3 of these. So we're going to have 2 to the 1 times 5, x to the 2 times 5, and y to the 1 times 5. So this would be 2 to the 5th, x to the 10th, y to the 5th. Now, in the rest of them, we were done because we couldn't combine anything else or solve anything else. But we can actually solve out 2 to the 5th. So we're going to go ahead and multiply that and give an answer because we can't actually solve it. So 2 to the 5th power is actually 32. So I'm going to put 32 for that. And then the rest of it has to stay because we can't combine. So to x to the 10th, y to the 5th. And there's your answer. Okay. So let's go to the next one. A little bit more involved as we move down to the bottom. Okay. So kind of like PEMDAS, we have to do one part at a time, right? So we see this guy has distributing going here, and then we're going to multiply by this one over here. So now we're starting to put the two properties together. This is our power to a power, and then once we get our answer, we're multiplying, so we're going to add exponents to both this side and this side. Okay, so let's do one thing at a time. Let's distribute first. I have x to 3 times 3 is 9, and then y, 3 times 3 is 9 again. So this is gone now, times xy squared. Now, this is a multiplication problem, so we're going to add exponents at this part. Okay, my x here has a 1, so I have x to the 9 plus 1 on this side. So this one and this one get added together, x to the 10th, and then this one and this one get added together. So y to the 10th. There's nothing else we can combine, so this is your answer. I'm sorry, that should have been, I apologize. This should have been 9 plus 2. Sorry about that. So this is 11. Okay, let's go to the next one. The first part, a to the third, is all by itself, so it's not going to change. So I'm just going to drop that down. Now, the second part has a power on the outside, so we're going to distribute it to the both on the inside. B, hopefully you're saying now, has a power of 1. So I'm going to have times a to the 8th, b to the 4th. Okay? Now, this is a multiplication, so I'm going to add exponents here. Okay? A's are the same, so they're the two that are being added together. 3 and 8 give me 11. And b to the 4th is by itself, so it just drops and stays the same. These can't be combined, so there's my answer. Okay, moving on. Same exact thing, just adding a little bit more in each time. All right, so now instead of just variables, we have a coefficient. So we're going to distribute this 2 on this side. So I'm going to go to the -2, the a, and the b. Remember, these both have a little 1 right here. So -2 squared would be 4. Okay, and if you didn't catch that part, I can kind of go back here a little bit. Let's go back one step. So this would be -2 squared, right? A has a 1, so it would be a squared. And then b has a 2, so this would be b to the 4th. Times, now it's going to be distributed over here. These both have a 1 as well. So this would be 3 to the 2nd, a to the 4th, b to the 2nd. Okay. Now, these can actually be solved, which is what I was doing earlier. So -2 times -2 is 4. So I can solve just this part. And then I still have a squared b to the 4th times 3 squared can be solved. So that's 9, a to the 4th, b squared. Now, this whole problem needs to be dealt with. So we're going to multiply the coefficients. 9 times 4 is 36. And then I'm going to add the like terms variables, right? Or exponents. So a squared is 2 A to the fourth over here would be 4, so this would be A to the sixth. B has 4 and 2 as well, so this would be B to the sixth. We can't put any of these together, and there's no more solving or simplifying. So then there's my answer. Okay. Let's go again. 6a squared b to the third power. So again, this is going to be distributed. These are all ones right there. So this is 6 to the third, a to the sixth, b to the third. Okay, and this is our new one, times. Now, 1/3 squared. So this is going to go here, then to a, then to b, then to c. So there's 4 terms in this part. 1/3 squared would be 1/9. Remember, it's like 1/3 times 1/3. So the tops stay and the bottoms get multiplied. Or multiply straight across, sorry, top and bottom. Okay? Then I've got a squared, b squared, c squared. Because these are all 1, 1, 1, and then a 1 up here. All right? Now we're back to having actual multiplying here, right? So I can actually take 6 to the third power, which is 216. These are going to stay, a to the sixth, b to the third. Nothing over here changes, so 1/9 a squared, b squared, c squared. And now I have to do all the way across. So these two can be multiplied together. 216 times 1/9 is like taking 216 divided by 9, which gives you 24. And now, because it's multiplication, we're going to add exponents. So I've got 6 and 2 for a, which makes a to the 8th. B has 3 and 2, which makes b to the 5th. And c is all by itself, so it's going to stay squared. And there's my answer. Okay, hopefully you're feeling a little better. All right, and we're just going to add more to it. So again, break it down little by little. If you don't like looking at this whole big thing, let's just focus just on this first part for right now, right? So we know it has to be distributed because it's on the outside. This has a 1, this has a 1. So we're going to distribute to 3 separate parts right here. So this will be 3 to the 4th. I'm multiplying here because I'm distributing x to the 12th and then y to the 4th. Okay, so that part's done. Now I'm going to uncover this. So let's just think about the middle part right here. 2 gets distributed to all 3 of these. So I have 7 squared, x to the 10th, y squared. I'm done with that. Then on the last one, there's nothing to distribute. So we're just going to write x squared, y squared. We can't do anything with it just yet. Now, this is a multiplication problem all the way across. We have 2 coefficients that need to be solved first. So let's take care of that before we get started. 3 to the 4th is 81. X to the 12th, y to the 4th. Times 7 squared is 49. X to the 10th, y squared. And then again, x squared, y squared stays the same. So the only 2 coefficients here are 81 times 49. And that gives us 3,969. Now, it is a multiplication problem, so I have to add my exponents. So x's, x's, x's. 12 and 10 is 22, and 2 more is 24. So x to the 24th. Then my y's would be 4, 2, and 2. So that means 4, 6, and 8. So this would be y to the 8th. And there's your answer. Okay, last one. Hopefully you're feeling okay. Again, let's do one part at a time. This is our first one, so it's going to distribute the 3 to both of these. I will have 2 to the 3rd, a to the 6th, times, nothing can be done to this guy, so a to the 4th stays. And this, again, remember, is parentheses, so it's just like another dot, multiplication, and nothing's going on over here. So I'm just going to have 3a squared. Now, I can actually simplify 2 to the thirds. Let's do that first. 8, a to the 6th, and then the rest drops again because there's nothing else to simplify on these. Okay, now we have two coefficients, 8 and 3. This is like having a 1 here, you guys. You already know that from previous stuff. But if you want to put the 1 there, that's fine. You're still going to multiply, and it's not going to change the answer. But 8 times 3 gives us 24. And then again, we're multiplying. So let's add all of these together. 6 plus 4 plus 2. So this would be a to the 12th. Okay. Hopefully you're feeling okay about these. Use the examples to go through, and please do these 4 at the bottom on your own for homework, and we'll go over them together when we come back to class on Monday or Tuesday. Okay? Let me know what you have trouble with. Have a good one.